Hello all, welcome to Excel Academy. So today we are going to make a video on the topic that is basic operations of signal problems. Okay. So I have already told you yesterday that we have missed so many questions wherein we are going to do one by one. So therefore in the case of that we are going to consider this particular question. See this particular question, that is x of c, question number C. That is what a x of 2t into y of t by 2 plus 1, right? That question was given in your question paper. So what we are going to do is, so we are going to take, so see in the question paper it is given that is x of, that is your 2t into that is y of, that is 1 by 2 t minus 1, right? So it has been given like that, but your 1 by 2t, please do note down that your 1 by 2t as well as and t by 2. So I'll just take an eraser over here. So let me erase this. So in your question paper I'll just rewrite it again and I'll show it to you in a clear manner. In the question paper it is given that your x of 2t into, so that is your y of 1 by 2t plus 1, right? Yes, 1 by 2t plus 1 is your question. So you need to make sure that your t by 2 and your 1 by 2t both are same, right? Yes, so you are going to make sure that your 1 by 2t and t by 2 both are same. So you need to first of all know that, okay? So then that means that this C question whatever is given is the same. In the C question is given y of t by 2 plus 1, but here it has been given 1 by 2t, both are same, right? Yes. So now coming on to the question, so this is what is the question that has been given, and now let us do for the particular C question now, because question number A and question number B have already done. Please do check it out in my video, right? So please do make sure that you check out the video for question number 1 and question number 2, and for question number 3 we are going to now do the solution, right? So now let me what I can say, start with my question. So see, observe the question carefully. So this is what is the question, and now let me come to this particular question number 3, right? So this is what is question number 3 and the answer is over here. And see, in the case of question number 3 you can see that the first question is my, that is your x of 2t, right? What is x of 2t? So 2t, I told you in the yesterday's class, in the divisions class, that it is a compression signal, right? So what is that you are going to do is, you are going to take this particular original signal into consideration and you are going to divide it by 2. So that is minus 1 by 2, that is a 0 by 2, that is 1 by 2, 2 by 2, and this is 3 by 2, right? So you're going to divide all these time periods by 2, right? Yes, all these time periods if you divide by 2, so what is that going to happen is, you're going to get the resultant like this. So your resultant would be this particular, right? So what is this? So this was your 1 by 2. So what is your 1 by 2? So your 1 by 2 is 0.5. So this particular is 0.5, right? This particular is 0.25 and this particular is 0, and this is once again, so for 1 if you divide it by 2 you are going to get once again 0.5. So this particular line I am drawing it over here. See, just a second. Is this particular is once again your 0.5. I'm sorry, I'm not getting it. Wait a second. Yes, it is 0.5. Please do make sure that it's 0.5, and this is minus 0.5 because this is minus 1 by 2 is minus 0.5, and this is 2 by 2 is 1, and you can see that this is 3 by 2, this particular part. I'll rewrite this again. See here, this is minus 1 by 2 is minus 0.5, this is 1 by 2 is 0.5, and this is 3 by 2, 2 by 2 is 1 over here, which is written, you can see this is 1, and here it is what? It is my 1.5, right? It's my 1.5, and so therefore you can see that this is what is the resultant you got, right? Now coming on to this particular, so how did you get this particular rays? So first of all, the given question is now y of t by 2 plus 1, or you can write it as that is y of, that is 1 by 2t plus 1. So now, so first let us do t plus 1 now. So in the case of t plus 1, so what is that going to happen is, so see here, t plus 1 is equal to 0, t is equal to minus 1. Let me do it here. T plus 1 is equal to 0, and your t is equal to what? Minus 1, right? So if your t is equal to minus 1, so then what is that going to happen is, for a t is equal to minus 1, you know that it is a left shift, because the value that is minus 1 is lesser than 0, right? So now you are going to make a left shift. So when you are going to make a left shift, what is that you are going to get as? You are going to get a signal like this. Just a second, I'll draw the signal. So yes, your signal would come like this. That is, your signal would be, so your original signal was like this, so your resultant signal would be like this. Let me just do it now. Yes, so this is what is the given, and you will shift. So your starting range was minus 2, so now what now it will become? It will go to minus 3, because it is one shift to the left. So your minus 1 place will be taken by 2, so minus 1 will go to 2 now, and then what is that going to happen is, from 2 you are going to get it to, so that is minus 1, so this one will come to minus 1, so that is, you will get it to, just a second, I'll write the signal now, just a second guys. So here you will get it, yeah, here only it is there, yes. So here you will get it as, so you will get it to, that is your minus 1, and wait, I'll draw the signal. Sorry for the distraction guys, just a second, I'll be drawing the signal now. So see here, sorry for the distraction guys, really sorry, I had to just confirm with the signal, so that is why I took some time. So see here, you can see that this is, so you had minus 2 would come to place of minus 3, minus 3 would come to place of minus 2, and your minus 1 would come to, what I can say, your 0 would come to place of minus 1, so therefore your amplitude comes here to minus 1, and then once again it goes to 0 like this, and once again you are going to get a signal like this. So this is what is the resultant, that is what, that is your t plus 1. So t plus 1 resultant, what is that going to happen is, whatever that was in the place of 2, you are going to get it to minus 3, and whatever in the place of what I can say minus 1, you are going to get it to minus 2, so each and everything gets shifted to one place to the left, right? So this is what is the resultant. So this is minus 1 here, and this is 0 here, right? And this is 1. This is what is the resultant that you got. So now what you're going to do, then once again you are going to divide it by 1 by 2. So when you divide it by 1 by 2, what happens? I already told you that when you divide this by all by 1 by 2, so what is that going to happen? You are going to get a what I can say, the expanded version of the signal. So when you get expanded version of the signal, so what is that going to happen here is, see, this is what is the resultant. So you can see that this is the expanded version of the signal. So what is, I'll make a list here. So just make a list here. So first let's start with minus 3. So what is minus 3 divided by my 1 by 2? So you get it as 2 here. So that is, you shift 2 to the upward, you get it as minus 3 into 2, which is what is my minus 6, right? Yes, minus 6. So that is what is here. And then just a second. Yes, this is minus 6. And now let me come to my another one. So what is the another one? So here minus 2. So what happens to your minus 2? So for your minus 2 divided by 1 by 2. So if you shift 2 here, so you get minus 2 into 2, which is equal to what I can say, minus 4, right? Minus 4. So here, where is minus 4? So here is your minus 4, right? Yes. So now coming on to my next one. So what is my next one? Minus 1. So if I take minus 1, so therefore what is minus 1 divided by 1 by 2? So which is equal to minus 1 into what I can say, 2. So you are going to shift 2 to upward side. So you get it as minus 2, right? So here it is minus 2. You got it? Yes, the points. So now once again coming on to your what I can say, the 0. So 0 by 1 by 2 is 0 itself. And coming on to 1 now. So if you come to 1 now, so what is 1? 1 divided by 1 by 2. So which is equal to 2, right? So see here it is 2. So you got to know the 4 points, right? My a time period, whatever I had my time period, that was in the given t plus 1 signal is, that is minus 3, minus 2, minus 1, 0 and 1. So for all the 5 time period, so you got to know what is the time period again after you divide all this by minus, all this by 1 by 2. So this was that particular time periods, right? Yes. So you got to know this was the particular time period. There are all the time periods here, but you need to check with a particular time period for this particular time period, right? In the sense, I am telling you that for this particular time period, if I divide it by 1 by 2, what is the resultant time period that I get? So that is minus 6. If I divide 1 by 2 to this minus 2, what is my resultant time period? That is your 4, right? If I divide this by 1 by 2, I get it as minus 2. And if I divide this by 1 by 2 to 0, that is here, this is 0. And here, if you divide this by 1 by 2, you are going to get it as 2, right? So this is what is I wanted to tell you now. So right. So now coming on to this. So coming on to your multiplication part. So your multiplication part is completely your, what I can say, the amplitude multiplication. So what is amplitude multiplication is? So see here, you can observe that till minus 1 there is no signal here, right? You can see that, right? So therefore now you can see that, so here also you need not to consider till minus 1. So this particular part will become equal to 0, right? 0 into this whole signal till minus 1 is 0, right? This whole part multiplied to 0 would become equal to 0, right? Yes. So therefore that is why there is no time period till 0. So I have written a straight line like this till minus 1, right? Yes. So that is what I show, that is what is written here. And now coming on to this particular triangle part. See this particular triangle part, I'll write it again. See, so here this particular triangular part, so you can see that this is from minus 1 to 0 period. So you can see that there is no the minus 1 to 0 period. This particular signal is what? This particular signal is my x of 2t. Just a second, I'll write it. So this particular signal is my x of 2t. Yes, 1 minute. This particular time period is my x of 2t and this is my y of t by 2 plus 1, right? This is my y of t by 2 plus 1. So you can see that. So see here, you can see that this is y of what I can say t by 2 plus 1, which is being written over here. This is x of 2t, right? So now at the time period, that is minus 1 to 0 time period. So see here, you can see, so this is my minus 1 to 0. It is not minus 1 to 0. So this is 1.5. So here it is 0.5, right? So 0.5 to what I can say, that is my for my time period, that is I can say, sorry for the glitches here. So it is for the time period, that is minus 1 by 2, that is what is that, that is lesser than t, that is lesser than 0. You can see that the my x of 2t signal, so that is what my x of 2t signal is not equal to 0, and my that is y of that is t by 2, that is plus 1 is also not equal to 0. So therefore what happens, so what happens is that your z of t is also not equal to 0. So therefore you get a signal like this, right? This is what is the signal you get. So from 0.5 to minus 1 you get a signal like this, right? Yes. So now coming on to this particular part, so I'll erase all of this now, so to make you more clear. Yes, yes. So now you got it. So what is that? So for the time period, that is this time period, that is what I can say, n minus 1 by 2, that is lesser than t, lesser than 0. So therefore you can see that for x of 2t is also not equal to 0, and your y of t by 2 plus 1 is also not equal to 0 for this particular time period. So this particular time period, so minus that is for minus 1 by 2 time period, so that is lesser than t, lesser than 0. For y of t by 2 plus 1 is also not equal to 0. So therefore I can say that my z of t is what I can say, it is not equal to 0. So therefore you get a signal like this, right? So now coming on to this particular time period, that is this part, so you can see that, so see here it is 1, so your amplitude is 1, right? For 0 it is 0, so for this 0 it is 0, for this 0.5 also it is 1, for 1 also it is 1, for 1 by 1.5 also it is 1, that is for 1 by 2 also it is 1, right? So see, for all the time periods, that is what your 0.5, your what I can say, your 1 comma 1.5, so it is your amplitude is 1. So for here also it is amplitude is 1, right? So therefore what is your 1 into 1? So your 1 into 1 is 1. So therefore you got this particular signal. For 0 it is 0. So you keep it as 0. You can see that here for that is 0.5, for this 0.5, and for this 0.5 here, it is what I can say, amplitude is 1. So as your amplitude of 0 is 0, so therefore what is that going to happen is, from 0 it will provide a drastic increase. So see here, this amplitude of 0 is 0 here. So as here 0.5 amplitude is 1, so therefore from 0 it will make a drastic increase to 1, right? So here it is a drastic increase to 1, and here this line is 0.5, right? Yes, this line is 0.5. I guess you got it right. So see here, you can see for 0.5, in both the cases, for 0.5 you have an amplitude of 1. This is one amplitude, this is one amplitude. So therefore what is that going to happen is, for both the cases you can see that, so here amplitude is 1 for 0.5. So therefore what happens, so here 1 into 1 would result in 1, that is amplitude of 1 again. So therefore as your amplitude of 0 was 0, so therefore as for 0.5 you got it as 1, so it made a drastic increase here. So it is a drastic increase. I have round marked in the red color, right? You can see this is a drastic increase of, or this is a drastic increase from 0 to 1 for 0.5. So now coming on to this one time period, so for one time period also amplitude is 1, right? It's sharing an amplitude of 1. So 1 into 1 is 1, right? For both it is 1, right? For here also for 1 it is 1, and for in this time period also it is 1, you can see. So therefore that is why 1 into 1 is what? 1. So 1 into 1 is 1. So therefore what you have to do is, what are you going to do is, you are going to extend the signal till 1, right? You are going to extend this till 1, because as 1 is also sharing the amplitude of 1, you are going to make an extension till 1. This is what is your extension till 1, right? So after that, for year 2, what is that going to happen? For 2, for 1.5 also it is 1, right? For 1.5 also it is what? 1 here. For 1.5 what? It is 1 over here for 1.5. But for 1.5 what is that happening over here is, it is drastically decreasing to 0 for 1.5. See here what happened is, I'll erase this and show it to you, just a second. Yes. So see here, you had an amplitude of 1 here, right? After 1 what happened? There was a drastic decrease to 0. For that is what? For this value, that is what here, 1.5, right? For 1.5 it was a drastic, what I can say, decrease to 0 here, right? Drastic decrease to 0. And here what happened? For 1.5 it is 1, right? For 1.5 it is 1. So therefore what is 0 into 1? So at 0, this was 0 amplitude over here, as it is a decrease. I have drawn a red mark here for the decreasing ramp signal, right? So see here it is decreasing, and for here it is 1. I have already highlighted. So therefore what is 0 into 1 is 0. So therefore what I can say? So what I can say, that it is a decreasing ramp signal over here, right? And as after 1.5 here there is no signal, so therefore 0 into this particular signal, the whole thing is 0. So therefore here it is, this line continues on, right? I guess you got it, right? How? Yes. So if you have not got, I'll just clearly explain you once again. So I'll draw the signal only over here. So therefore let me draw the signal, just a second. So let me, yes. So see here, so this signal, what happens over here is, so you can see that for this signal it is, so here you did not have any of the signal, right? So therefore till 1, from here till 1 you need to consider it as 0, as you don't have any signal. So that is why I am drawing, till 1, I am taking it as 0, right? Yes, till 1 I'll draw a line over here. So for till 1 I'm taking it as 0, right? So now after 1, so that is, let me start from my 0.5 time period, right? So here let me start with my, yes, let me start with my 0.5 time period. So here for the case of 0.5 to, that is your 0 time period, that is what I can say, that is I can say for here, that is minus 1 by 2, that is time period for minus 1 by 2, that is lesser than t, lesser than 0. You can see that for this particular x of 2t signal, this signal, your x of 2t is not equal to 0, right? X of 2t is not equal to 0, and your y of, that is 2t by 2 plus 1 is also not equal to 0. So our z of t is also not equal to 0. I already told you, right? So therefore what is that going to happen is, you are going to get a signal like this, right? Yes, you are going to get a signal like this. So this is 0.5, just a second. Yes, yeah, it is 0.5, and then here it is 0, right? So now coming on to here, what I can say here, 1. So from starting from this particular, let me consider this particular now. So if I consider this particular now, so what is that going to happen is here, so see, red one only, yes, here, so see, you can see that 0 is only 0. So now what is that going to happen for 1.5 here, this line is 1.5, right? I'll just a second, I'm sorry. Yes, so see here, for this particular, I'll just erase this and I'll show you again. So for this 0.5, I can say that it is 1, right? For here also for 0.5 it is 1. So now if you consider, for this minus 1, So for the 0.5 it is 1, and for 0.5 here also it is 1. So what is that going to happen is, for 0 it was 0, but as for your 0.5, in both the signals, in this signal as well as this signal, you are getting the amplitude as 1. So 1 into 1 results in 1. So therefore for 0.5 you get an amplitude of 1. So because of that, what are you going to do is, you are going to drastically increase the signal like this till 1 for 0.5. So this line is what I can say, my 0.5, right? My 0.5, right? Yes. So now coming on to here, this is 1, right? So after that you can say that so after that, here what you have to do is, you have to just now for 1 it is 1 here, and for 1 here also it is 1, here also it is 1. So therefore it is amplitude is 1, so I extend till 1, right? So after that, for my 1.5, here it is drastically decreasing to 0, but here you have an amplitude of 1. So therefore here it is 0, here it is 1 for 1.5. So therefore 0 into 1 is 1, so 0 into 1 is 0, sorry. So what I can say, so it is drastically decreasing to, so here it is drastically decreasing to, that is 0. So this is my 1.5, and after 1.5 I don't find any other signal. So therefore what I can say, I can say that it is what, it is the a 0. So it continues like this. So this is what is the resultant signal, right? So I guess you got it right, how to do this particular problem. So therefore this is what is one problem. So we'll do another problem now.